Now that we've learned about Newton's laws, and much like Newton's first law,
things are now in motion that cannot be undone.
Now it's time to learn how to
use the force, Luke.
Roll the intro.
Do you feel the vibes?
There are two main types of forces, and two subtypes of forces. The first main type is field forces.
No force fields! You started it.
There's only one field force that we're going to look at in this class, and it is
G-force.
Blaster, do something! What do you suggest I do?
Hoop in his hand! Hoop in his hand!
the G-force, or gravitational force, also known as weight more commonly, is just the mass of the object times the acceleration due to gravity. This comes from Newton's second law, where force is equal to mass times acceleration. Since we know the equation for this fits into the first subcategory of forces, or what I like to call non-variable forces. These are forces that we know the equation for and can use them outright. This means that the force of gravity on an object is always equal to the weight of the object is always the mass of the object times the acceleration due to gravity. It doesn't change unless you change the planet that you're on.
Hippity hoppity, hippity hoppin' over hill and dale.
Since that's the only field force we're going to be looking at in this class, let's start looking at the other type of force. It comes from
Unwanted physical contact.
Contact forces are when any two objects are connected to one another, or when they're pushing up against one another. Keep in mind that in Newton's third law, that means that the two share a force between them. The force of one object on the other will be equal to the force of the other object on the first.
No substitutions, exchanges, or refund.
Contact forces can be broken up into the two main subtypes. This would be non-variable and variable. The first one we're going to look at is a non-variable force, or one that we know the equation for. The spring force, being non-variable, has a set equation. That equation is governed by something called Hooke's law, which is that the force of a spring is due to the negative of the spring constant, K, times the stretch distance of the spring, X. Note that the X in this case is not necessarily where the position of the spring is, but rather the displacement along the length of the spring from its original position, or equilibrium position, which is when the spring is applying no force because it has not been stretched. If a spring has a position that is naturally in a stretched state, you could also compress the spring. This follows Hooke's law the exact same way that a stretch does. Notice the negative sign in the equation. This means that as our hanging weights that are shown in this picture go down due to the force of gravity increasing, the spring stretches downward, and that causes an upward force, meaning that the force from a spring is in the opposite direction of the stretch of the spring. Likewise for compression. You can see that in action here. When a person opens the gate with a force, they stretch the spring using that force. Then, when they no longer apply that force, the force from the stretched spring pulls the gate back shut. The spring constant K is just a measure of how springy your spring is. It's a physical constant related to the actual spring itself. So this number will either be something that's given to you or something that you will be solving for. There's no way to find it, in this class at least, otherwise. And that's it for linear Hooke-type springs. Don't worry, there are more complicated ones, but we won't deal with them in this unit. We'll get to them at a later time. Our next set of forces that we're going to look at will be the variable forces. Variable forces are any force that you do not have a direct equation for without looking at the physical situation at hand. They're something that will either be given to you in the problem or something that you will be asked to solve for. So basically, if you ask for the value of the force, the answer is
Depends.
Depends. Depends on what?
I mean, honestly, it depends on how hard you push it.
Push it real good.
Now, I know you might,
Hate all this uncertainty.
but it'll be all right. We'll just have to solve for it using algebra and the setup of our equations. There are many different variable contact forces. For example, you could be starting the engine on your car. Could be pushing a baby around in a stroller. You could be loading your laundry, or even lifting weights. These are all examples of human-made forces, which certainly fall under the variable category. But there are also some that aren't human-made. We're going to take a look at two of the major ones that we'll use in this class. The first one we're going to look at is the normal force. It's called normal not because it's average or menial or, neurotypical. It's called normal because it's normal to a surface. That means that it's perpendicular. In this picture of the stacked rocks, you can see that the bottom rock, which has a surface on top of it, is holding up the other three rocks that are sitting on top. That's because the upward acting normal force is enough to combat the downward acting gravitational force from the weight of those rocks above. This is very common for normal force. This is why you can stand on a floor. But normal force is not limited to going up and down. It can also be sideways, as long as you're pushing against a surface, like this kid. Now, the next force we're going to cover might make you a little tense. In fact,
so thick you can cut it with a knife.
that's right, it's tension. Now, while tension is important in any good story, and the Naruto swing set is a perfect example of this, it's also held up by ropes, which is why, tension. Tension is caused by any kind of string or any other kind of rope-like thing that only pulls. So think about it this way. A normal force can only push against the surface. A tension force can only pull along the length of the string. So it will always be along the direction of the string, and it will always pull, never push. All right, that about wraps it up for this video on different types of forces. So until the next one, don't forget to go perpendicular to the surface and
Be normaler.
don't forget to like, comment, and subscribe. Appreciate it.